My name is Walker Rowe. I'm a computer programmer, tech writer, tech philosopher. Today I'm going to explain to you who George Boole and Claude Shannon are. Most people probably don't know who Shannon is. They might know who Boole is if they're computer programmers, but these men are heroes, and without them we would not be where we are today. These men did more than perhaps anyone to create computer chips. We'll also talk about in another video about Alan Turing, as he made important contributions. Okay, without Boole's work on logic and Shannon's work on electric circuits, there would be no computer chips. I'm going to show you exactly how Boolean logic and Shannon's electric circuits work together to create logic gates. Today we call those computer chips. I explain how Claude Shannon's circuits do math in another video, as it's a longer topic. George Boole put forth the important idea that deductive logic and algebra are the same. He took the rules for formal logic and showed they could be expressed as algebraic expressions. This was important for computers because these statements had two values, true or false. Here are our Boolean operators. The plus means a union of two sets, which is also represented by the symbol, the letter U. The multiplication symbol, which is also the upside down U in Boolean notation, is the intersection of two sets. The union means to take two sets and make a new set that contains the elements that exist in both sets. Here is an example. The universal set is 1. The intersection of the universal set with the universal set is the universal set. Obviously, the universal set contains everything. So if we have 1, then we can't have another one. It's the same one. We have our notation, the curly braces is the empty set. So is the O with the slash through it. Let's look at an example. Suppose we can have either hot days H or cold days C, and rainy days R, sunny days S. Here, using our Boolean algebra again, we can see that the intersection of the hot and the cold set is the empty set, or the curly braces, or the O with the slash through it. Can be cold or hot, but not both. Hot and rainy is just the intersection of hot and rainy. Of course it can be hot and rainy. Same thing for hot and sunny. The union of hot days and cold days is H union C, written using the U sign. We can write this as well using the plus sign. The plus sign also means the union. The union of cold and sunny is C plus S. The union of cold and rainy is C plus R. We can put parentheses around these to represent them as individual entities. So cold and rainy is C plus R, plus cold and sunny is C plus S. 1 minus C equals H. This means all days, 1, not including the cold ones. So those are the hot days. 1 means the universe, which means all possibilities. We can use a Venn diagram to illustrate. If we have hot as the orange area and then cold as the blue area, the intersection of hot and cold is the empty set. They are tangent to each other, meaning there is no overlap. Can it be hot and sunny? Of course it can. So the intersection of hot and sunny is the area between the orange and yellow places, which is kind of oranges. And can it be cold and rainy? Of course it can as well. So rainy is gray, cold is blue. The intersection is the lighter cyan blue. Okay, we can read from this diagram the definitions of a union and intersection. Now, union can also be represented as the plus. The union of the empty set with the universal set is 1. Obviously, nothing plus everything equals everything. We get this by looking at the table on the left, the plus sign. The empty set is on the top row on the left. The union of that with the bottom element on the left is the universal set. Read where the two lines meet together. That's how you read the table. Then the intersection of the universal set with the empty set is the empty set, following the same pattern. So the universal set is the 1, bottom left. The empty set, top left, between the two lines. And 1 times 0 is equal to 0 is the empty set. Boolean logic to electric circuits. In 1937, MIT student Claude Shannon showed how electric circuits followed the rules of Boolean logic and algebra. He says our notation is taken chiefly from symbolic logic. Boolean is symbolic logic. In modern notation, we call a closed circuit 1 and an open circuit 0. Electricity can flow across a closed circuit, but not an open one. So circuit has two states. 1 equals closed circuit, current can flow, or true. 0 equals open circuit, no current, false. Fun historical note, Shannon originally labeled these the opposite way. He measured hindrance. So for him, a closed circuit was 0, as there was no hindrance. Engineers later flipped to the convention we use today. For the rest of this video, we'll use the plus and multiplication operators as follows. X plus y means x or y. X times y means x and y. In terms of wiring, x plus y means a parallel connection of switches. Parallel means 2 wires with 1 switch on each wire. Think OR. Because the light comes on when either X or Y are open. Because each wire has its own switch. Electricity has 2 different paths it can travel. X times Y means a series. Think AND. Because the light comes on only when both X and Y are closed. Series means 1 wire with 2 switches. Here we have an electric circuit with 2 switches, X and Y. If both of these are closed, electricity can flow through the circuit and the light turns on. Okay, here we see the expression A plus B in parentheses plus C. What this means is that we have on the top 1 circuit wired in parallel, and those together can consider one entity, A plus B. On the bottom we have C. So A plus B is wired in parallel with C. Okay, then moving on to the next diagram. Here we see an application of how the distributive law of multiplication can help us simplify a circuit. Here we have A times B plus A times C. Both terms contain A, so using the distributive law, we factor out A. The result is A times, in parentheses, B plus C. The original circuit used 2 separate A switches. The simplified circuit uses only one A switch in series with the parallel combination of B and C. In this way, Boolean algebra lets us simplify the circuit and eliminate one of the A switches. Now this last example here. This is the network for W plus X times, in parentheses, Y plus Z times X prime. Okay, now notice here. The relationship between bottom is wired in parallel with what comes above it. What comes above it is X wired in series with what's to the right of it. What's to the right of it is X times the items that are wired in parallel. Y on top and Z times X prime on the bottom. Now X prime means not X or X complement. That's the definition of a relay, sort of. The most famous well-known relay today is the telegram, the telegraph wire. So hopefully that's useful. Hopefully you understand how Boole's logic and Shannon's work on electric circuits using that logic came together to create what today is computer circuits. They laid the groundwork to make computer circuits possible.